In this video, we want to find the integral from negative infinity to positive infinity of e to the negative x squared over 2 dx. So let's let I equal this integral, and we're going to square both sides. So when you square both sides, you technically have I squared equals integral from negative infinity to positive infinity, e to negative x squared over 2 dx, and the same thing, same integral. Now, I can change the x in the second integral to be y. So instead of e to negative x squared over 2 dx, we can have e to negative x squared over 2, or e to the negative y squared over 2 dy. And this is equivalent because all I'm changing is the variable. I'm still integrating it from the same negative infinity to positive infinity. Now, using Fabini's theorem, I can bring this as a double integral. And then I'm going to, because I'm multiplying e's here, I'm going to add the exponents. And then from here, I have to convert this into polar. So we're going to make a substitution. We're going to let x equal r cosine phi, which means y equals r sine phi. And we know that x squared plus y squared equals r squared, because you have r squared cosine squared phi plus r squared sine squared phi. Factor out the r squared, and then cosine squared plus sine squared is 1. So that's going to give us r squared. Now, in order to make the substitution, we need to find the Jacobian, which the Jacobian is a 2 by 2 matrix. In the first row, we have dx over dr and dx over d phi. The second row, we have dy over dr and dy over d phi. Find the derivatives. We have cosine phi, negative r sine phi, sine phi, and r cosine phi. Now we need to take the determinant, which is cosine phi times r cosine phi minus sine phi times negative r sine phi. Here we can factor out an r. We see that cosine squared plus sine squared is 1. R times 1 is r. So that's going to go inside the integral. And then we're just going to change the r and the d phi. So instead of dx and dy, we're going to have dr, r dr d phi. And the phi is the angle. Here we're looking at from 0 to 2 pi, because if you're looking at a parametric equation, x equals r cosine phi, y equals r sine phi, that's just going to be a circle which goes from 0 to 2 pi. Now, because x and y are going from negative infinity to positive infinity, the radius is going from 0 to infinity. We have to use the u substitution to solve the first integral. We let u equal r squared over 2, which means du equals r dr. So now we have to integrate e to the negative u from 0 to infinity. Well, the antiderivative is just negative e to the negative u. Now go from 0 to infinity. Well, negative e to the negative u, when u approaches infinity, is just 0. So this is 0, and then minus. If I plug in u equals 0, it's negative e to the 0 power, which is negative 1. And that's just going to give us 1. So now we just have to integrate 1 d phi from 0 to 2 pi. That's a constant, so you can just multiply it by 2 pi. And this is our final answer.